Electric charge noted by the letter capital Q. We know now all matter is composed of positively charged particles called protons and negatively charged particles called electrons. Thus, charges are of two types, positive charges and negative charges. What are the properties of these charges? Like charges repel each other. For example, a positive charge repels a positive charge, whereas a negative charge repels a negative charge. Unlike charges attract each other. For example, a positive charge attracts a negative, whereas a negative charge attracts a positive. A proton carries a positive charge of 1.6 into 10 raised to minus 19 coulomb, whereas an electron has a negative charge of 1.6 into 10 raised to minus 19 coulomb. The charge of a proton and an electron is very feeble, so we use a bigger unit to measure electric charge, and that unit is coulomb. 1 coulomb is the charge of 6.25 into 10 raised to 18 electrons. Thus, the SI unit of charge is coulomb. The amount of charge Q in a body is given as Q is equal to NE, where N is the number of charges or electrons and E is the charge of an electron. Electric current noted by the letter I. When a conductor is connected to a source of electricity, electrons start moving from one end of the conductor to the other. They are the charge carriers and they constitute the flow of charge. Hence, electric current is defined as the amount of charge flowing through a particular area in unit time. If a net charge Q flows through any cross-section of the conductor in time t, then electric current can be calculated using the equation electric current I is equal to Q by T, where Q stands for charge and T stands for time. Hence, the SI unit of electric current is found by knowing the SI units of charge and time. Hence, coulomb per second becomes the SI unit of electric current, that is ampere. So 1 ampere is the current produced when 1 coulomb of charge flows through a conductor in 1 second. Small quantities of current can be expressed in milliamperes and microamperes. 1 milliampere is equal to 10 raised to minus 3 ampere, whereas 1 microampere is equal to 10 raised to minus 6 ampere. Conventionally, the direction of electric current is taken as opposite to the flow of electrons, that is from positive to the negative terminal. Potential difference or voltage noted by the letter V. We know now that electric current is the flow of electrons, or simply the flow of charges. But these electrons don't move by their own. There is a cause. When we hold a wire or a conductor in our hand, there is no flow of charge, as we know that matter is electrically neutral. But when it is connected to a source of electricity like a battery or a cell, the chemical action or the chemical energy stored within the battery is the one that causes the electrons to move from one end of the conductor to the other. As we all know that water moves from high level to low level. Air moves from high pressure region to low pressure region. Likewise, electrons move from high potential to low potential. The two terminals of the battery are at two different potentials, and this creates an electric pressure difference that causes the flow of electrons from one end of the conductor to the other. Thus, potential difference can be defined as the work done to move a unit charge from one point to another. If W is the work done or the energy spent by the battery to move a charge Q from one point to another, then potential difference can be calculated using the equation V is equal to W by Q, where W stands for work and Q stands for charge. And the SI unit of potential difference becomes volt. 1 volt is 1 joule per coulomb. Hence, 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move 1 coulomb of charge from one point to another. Thus, potential difference is the cause and electric current is the effect. Let us now talk about the measuring devices ammeter and voltmeter. Ammeter is a device which measures electric current in a circuit. It is always connected in series to a circuit. You can see a circuit and there you can see ammeter connected in series to the resistance. And also ammeter has a low resistance so that it doesn't change the value of current that is flowing through the circuit. Voltmeter. Voltmeter is a device which measures the potential difference across a circuit. Also, it is connected always in parallel across 2 points in a circuit. It has a high resistance so that it draws negligible current from the circuit.